Hello everyone, my name is Dr. Yogesh Valla, Associate Professor in Mathematics, GNI University. So today we are going to discuss about differential equations. So basically what is a differential equation? An equation consisting of differential coefficients is known as a differential equation. Now what is basically differential coefficients? dy by dx, d2y by dx, they are known as differential coefficients. For example, dy by dx or second order d2y by dx square and so on. For example, dy by dx plus 2y is equal to 3x square is a differential equation of order 1, because here I have taken one time derivative, that is known as first order differential equation. Again this one, second example, here we are having d2y by dx square minus 3 dy by dx plus 2y is equal to 7x, that is also a differential equation. Now when we study about differential equation, the two terms we mainly discuss, that is order and the second one is degree. Order relates with the number of times derivative and degree means power, or we can say index of highest order coefficient existing in that differential equation. Now if I look it over here, so in this equation the highest order is 1, so that means its order will be 1, and degree, that means the index of that derivative, so it will be first order and first degree. Now here if I discuss about this equation, so here we have the highest time derivative we have taken, that is second, so it will be of second order, and degree will be what? Degree will be the power of this one, that is 1, so degree will be 1. Let us take one more example for this one. Three d2y by dx square minus 7x dy by dx plus 8y is equal to 0. Now in this equation the highest order coefficient is this part, that means the order of this equation will be 2, and the index, the power of this coefficient is 1, so its degree will be 1. I'll take a second example, let it be 3 times d2y by dx square minus of 5x into dy by dx whole cube plus 7y is equal to 9x square. Let it be a differential equation. Now here the highest order derivative is this part, so here order will be again 2, and degree, what about degree of this one? Its highest order will have a power 1, so that means its degree will be 1. I will not consider this part because its derivative is first time, okay, so that means its power will not to be considered. Here the order and degree will be for this part, okay. Now when we consider about differential equations, so we face two types of differential equations. The one that is known as ordinary differential equation, and the second one is known as partial differential equation. So what is the basic difference between them? We will study this one. Now, when we are discussing about ordinary differential equation, here we have one differential coefficient which is dependent on one independent variable. For example, y is depending upon a single variable x, so we can calculate either dy by dx or we can calculate d2y by dx square or d cube y by dx cube. That means if y is a variable and x is a dependent on y, so that means we can take the derivative, and the equation which consists of such type of derivatives is known as ordinary differential equation. Now if I come about partial differential equation, so those equations which consist of partial differential coefficients is known as partial differential equations. For example, now if I take f of z, we have a function and it is depending upon two variables x square plus y square. Now if I take derivative of this one f, so we have a choice that I can take derivative of function f either with respect to x or with respect to y. So its derivative will be curly f by curly x, as well we can take derivative curly f by curly y. So those equations which consist of partial differential coefficients, they are said to be partial differential equations. For example, I am taking curly to u over curly x square plus curly to u over curly y square is equal to 0. Now this is a partial differential equation of second order. I think so everything is clear to everyone. Now coming to the solution now. Solution of differential equations. So when we are discussing a differential equation, so most of the differential equations have a solution, but we have to reduce those differential equations in the few categories. The first category is basically variable separable form. Second is differential equation of the form dy by dx is equal to f of ax plus by plus c. Number 3, that is homogeneous differential equation. Fourth one is linear differential equation, and the fifth one is exact differential equation. So now we will be discussing each of them one by one, starting with the variable separable form. So what is the variable separable form? Those differential equations in which we can separate the 2 or 3 variables easily, they are said to be variable separable form. For example, if I am taking a question Okay, so this is a basic question for variable separable form. Here we need to separate all the variables. Here we have a term, this part, that is totally dependent upon x. This is a term that is totally dependent upon y. again dependent upon x and dependent upon y. What we do in this type of questions, we separate all the variables that are depending upon x on one side and the variables of y on the other side. So we will take 3 times e raised to power x tan y dx is equal to minus 1 plus e raised to power of x secant square y dy, and then I'll take, now this term tan y is not dependent upon x, so I'll take it on the other side. Here this term is not dependent upon y, so I'll take it on the other side. So it reduces to e raised to power x over 1 plus e raised to power of x into dx is equal to minus of secant square y divided by tan of y dy. Okay, now we know that we have a term 1 plus e raised to power x that is totally dependent upon x type, and this is the term which is totally dependent upon y type. Now I integrate both of the sides, so 3 e raised to power of x over 1 plus e raised to power x dx is equal to minus 1 integral secant square y over tan of y into dy. I need to integrate. So for that one, now look, 1 plus e raised to power x has a derivative e raised to power x, and tan of y has a derivative secant square y. So I am using the formula f dash x over f of x dx that counts to be log of f of x. Okay, so this equation reduces to 3 times log of 1 plus e raised to power of x is equal to minus log of tan of y, because derivative of tan y is secant square y. So using the same formula, it will be plus a constant, let it be log of c. Now using the property of log, 3 comes to the power, log of 1 plus e raised to power x whole cube is equal to minus log of tan y plus log of c. Here I will use the formula of log m minus log n. So it will be log of 1 plus e raised to power x whole cube is equal to log of c divided by tan y. Formula used, that is log m minus log n, that is equal to log m over n. Now since we are having both of the terms in terms of log, so log and log both will cancel by using anti-logs. So result will be 1 plus e raised to power x whole cube is equal to c over tan y, or we can also write it as tan y is equal to c over 1 plus e raised to power x whole cube, or it can be written as c times 1 plus e raised to power x raised to power minus 3. So this will be the solution of the given differential equation. Okay, now coming to the next question now. Now the next question is x cos y Okay, so the second example is x cos y plus sin y dy by dx equal to 0. What I do now, x cos y is equal to minus of sin y dy by dx. Now I'll take this dx to the other side, so it will be x cos of x dx, and this cos y to the y variable side, that will be minus sin of y over cos of y dy. Now I'll integrate both sides. So integrating will be x cos of x dx equal to minus integral sin y over cos of y dy. Now here we'll apply u into v form. So first function as it is, integration of cos of x will be sin of x minus integral derivative of first, that is a1, integration of cos will be sin of x and dx is equal to, now here I'll apply the property cos of y have a derivative minus sin y, so minus sin y over cos y. To balance this minus, I'll adjust this with positive sign dy. Now it will be x sin x minus, now integration of sin x will be minus cos x, so minus minus plus cos of x is equal to, here it will be f dash, I am applying the property f dash x over f of x, so this will be having a formula log of cos of y mod plus log of c. So we reduces to the solution now, that log of cos of y is equal to x sin x plus cos of x minus log of c, or we can substitute this value log of c as only c. Okay. Now coming to the type of second type, type 2, that is differential equations of the type dy by dx is equal to f of ax plus by plus c. In such type of equations, what we need to substitute this part is equal to t, and we'll convert all of the question in terms of dy by dt or dx by dt depending upon the situation. So let us take a question from that part. So question is x plus y plus 1 whole square dy by d of x is equal to 1. Now this is the statement, x plus y whole square dy by dx is equal to 1. Now we can check this, the whole term is in bracket and they are consisting of the terms x, y and a constant over there. So I'll substitute x plus y plus 1 is equal to t. Now such that since we are having a derivative of y with respect to x, so we'll differentiate this equation with respect to x. So derivative of x will be 1, derivative of y will be dy by dx, derivative of constant will be 0 and dt by dx. So dy by d of x is equal to dt by d of x minus 1. Let it be equation 1 and this is my equation number, this is substitution 2, this is my third. Now I'll substitute the value of equation number 3 in equation number 1. So what will be the result? So this equation reduces to the form, now this is what? This is basically t. So it will be t square and dy by dx is basically dt by dx minus of 1 bracket is equal to 1. So just expanding the brackets, so it will be t square dt by dx minus of t square is equal to 1, or t square dt by dx is equal to t square plus 1. Now I'll take this t on the other side, so it will be dt by dx is equal to t square plus 1 by t square. Okay, now On this side we are having a term that is totally dependent upon t, and here we have dt by dx. So now I apply variable separable form. So in that case it will be t square over t square plus 1 into dt is equal to dx. Now here we are having now we have done the t variable on one side and x variable on the other side. Now I'll integrate both of the sides. Before doing that, we need to check the index of both of these terms, numerator and denominator, both are equal. So I use the property 1 plus of t square minus 1 over t square plus 1 into dt is equal to dx. So 1 plus of t square over 1 plus of t square minus 1 upon 1 plus of t square into dt is equal to dx. Now these two cancel out. I got the value 1 minus 1 over 1 plus of t square into dt is equal to dx. And now after this one, I'll integrate both of the sides. So integral 1 minus 1 over 1 plus of t square into dt is equal to integral of dx. So integration of 1 with respect to t will be t minus. Now this is the formula for tan inverse t. So it will be tan inverse t is equal to x plus of some constant c. Now this is not the answer because the question was in terms of x, y. Here the result, the answer is in terms of t and x. So I need to substitute the value of t. So the value of the t we have substituted x plus y plus 1 minus of tan inverse of x plus y plus 1 is equal to x plus c. Now I'll take this x on the other side. So it will be x plus y plus 1 minus x minus of tan inverse x plus y plus 1 is equal to c. Minus x and plus x cancelled out. So we get the result y plus 1 minus of tan inverse x plus y plus 1 is equal to c. So this is the answer for this type of equations. Okay. Taking one more example from this concept. So second example is dy by dx is equal to sine of x plus of y. So in this case again x plus y is in brackets. So I'll substitute x plus y is equal to t such that derivative of x will be 1 and derivative of y with respect to x will be dy by dx is equal to dt by dx. So this was equation number 1 and this is my equation number 2. So substituting the value of equation 2 in equation 1. So dy by dx will be dt by dx minus 1. So dt by dx minus 1 is equal to sine of t. Or what we can do, dt by dx is equal to, I'll take this minus 1 to the other side. So it will be sine of t plus 1. That means we are having the term dt by dx is equal to 1 plus of sine t. Now I'll separate the variables. Take all the t variable on one side and x variable on the other side. So it will be 1 over 1 plus sine t into dt is equal to dx. Now I need to integrate this part. Now before integrating, I must know how to integrate this part. So this part can be integrated by fraction by using rationalization method. 1 over 1 plus sine t into 1 minus sine t over 1 minus sine t dt is equal to dx. So it will be 1 minus of sine t divided by a plus b, a minus b, a square minus of b square into dt is equal to dx. So I'll use 1 minus of sine of t over 1 minus sine square t, that will be cos square of t, dt is equal to dx. Now I'll separate the both of the term. 1 upon cos will be secant square t minus sine upon cos square, that means sine upon cos, that will be tan of t, into 1 upon cos will be secant t, bracket dt is equal to d of x. Now I'll integrate both sides. Integrating both sides, so we'll come with integral of secant square t dt minus integral of tan of t into secant of t dt is integral of dx. Now what will be the integration of secant square t? That will be tan of t minus, now integration of tan t into secant t, that will be secant t is equal to x plus of c. Now this is not the right answer right now, because the question was in terms of x and y and we are getting the result in terms of t. So I need to resubstitute the value of t, that is tan of x plus y minus secant of x plus y is equal to x plus c. So this is the final answer. I hope the topic of second type is clear to everyone. That's it for today. Thank you.